This is part 3 of 3 properties of logarithms, condensing logarithmic expressions to a single logarithm. So when we condense our logarithmic expressions, we have to use the 3 rules of logs. They are: the log of a product is the sum of the logs, the log of a quotient is the difference of the logs, and the log of something to a power is the power times the log of that something. So what we need to pay attention to is things like positive plus signs, keeping in mind that there's a plus sign here, and minus signs like this. So if we have a plus sign, that means when I condense it, it's going to be in the numerator. So we're going to have 3 times 5 in the top. And if there's a minus sign in front of it, that means it came from the denominator, and we'll have 4 times 6. So in this particular case, we have log of 15 over 24, which we could reduce. Let's do that. We could have canceled here and gotten log of 5/8. For our next example, we also have a sum. So when I condense it, it's going to be a product. The log of 2x to the 4th times 3x to the 5th, or the log of 6x to the 9th. Now remember, we don't have a rule for the log of a difference or the log of a sum, but I do have a log minus a log, which is this second rule here. So we will have the natural log of 3x minus 1 over 3x squared plus 5x minus 2. So it's not a log divided by a log, but a single logarithm. And let's see if I could simplify this as well. So if I factor my denominator, I need 2 numbers that multiply to -6 and add to 5, so +6 and -1. So we'll get x plus 2 and 3x minus 1. And so I have the natural log of 1 over x plus 2. For our third example, or fourth example actually, we can move these numbers that are in front of the logs back up as exponents. So this will give us the log of x squared plus the log of x plus 1 cubed. And now I have a log plus a log, that's the first rule, the log of x squared times x plus 1 cubed. So let's take a look at some expressions that we should be able to simplify without a calculator. So for example, if I move this 8 down in front of my log, I have 8 times the log base a of a, and we know that the log base a of a is 1, so we get 8 times 1, or just 8. For our next example, we can bring the negative t down in front of the natural log of e. The natural log of e is also 1, because we're saying what power do we have to raise our base of e to get e, and that's 1. So negative t times 1 is just negative t. In this case, we can bring our 3k down in front of our logarithm. Log base 10 of 10 is also 1, so we just get 3k. This is one that we talked about earlier. 4 to the log base 4 of k. If this base and this base match, we just get k. Same thing here. This is e to the log base e of 5. That's the same rule. This base and this base match, so we just get 5. And in this case, this base and this base match. We don't write the 10 there, but we just get 7t. Something else you may see in your homework is to expand expressions using given information. So in this case, we're told that log base a of 2 is approximately 0.301. and log base a of 3 is approximately 0.477. And we're asked to evaluate log base a of 6. So we need to rewrite log base a of 6 using only 2's and 3's. So that'll be 2 times 3, which is log base a of 2 plus log base a of 3. And we were given these numbers, 0.301 plus 0.477. That will give us a total of 0.778. See if you can do the same with part B and part C. So pause your video and we'll see if you get these. So for our first example, it's the log of a quotient, so I broke it up as the difference of logs. And for part C, I recognized 81 as a power of 3, so I wrote log base a of 3 to the 4th, and then I brought my 4 down in front. That concludes this video on condensing logarithmic expressions.